This is section 3.7, and it is on implicit differentiation. So we have the rules, but now sometimes we're going to come across an equation in the form y equals f of x that isn't where y is on one side and everything else on the other side is in terms of x. So if we can't do it the usual way, we may be able to use implicit differentiation. And the two rules differentiate both sides of the equation with respect to x, and you treat y as a differentiable function of x. In other words, every time, so if you have a 4x squared, you do that what we've been doing all along, and that would be 8x. If you have 4y squared, you do it the same way. You have 8y, but you have to put a tag on it, dy dx, saying this is with respect to x. So anytime you take the derivative of a y term, it will be with respect to x. So that is what, that's what we're going to do. And also we have one problem that talks about a tangent line and a normal line. And we need to see the difference here. In this curve, this blue curve, this is a tangent line. The normal line is perpendicular to that tangent line. So keep that in mind as we move toward, I believe it's the last question in the problem set. So have that in mind. All right, let's go look at our problem set. All right, so number one says 3x squared y plus 4xy squared equals -4. So this is definitely not in the form y equals and you have stuff on the other side. So we're going to differentiate each side with respect to x. All right, so every term we will do. Now this is a product and this is a product, this is a constant. So you can see automatically the derivative of -4 is 0. But here we've got this first product. First times derivative of the second plus second times derivative of the first. And then same way for this product. There's 4 places now that we've got to take the derivative. So here the derivative of y is 1, but it's dy dx. So we have a dy dx there. The derivative of 3x squared is 6x. Derivative of y squared is 2y dy dx. And the derivative of 4x is 4. So in that line, all we did was take those derivatives. So this should be your pattern. Roadmap, take the derivatives where you need to. Then you start collecting and cleaning up. So we have 3 squared dy dx plus 6xy plus 8xy, that was 2 times 4, and the x times the y, dy dx plus 4y squared equals 0. You want to leave all of your dy dx's together and make it sure everything on the other side does not have a dy dx. So I subtracted this 6xy and the 4y squared to the other side. All right, now the goal is to solve for dy dx. That means I'm going to factor dy dx out. What's left is 3x squared plus 8xy. I want this to be by itself, so I divide both terms by this 3x squared plus 8xy. Those cancel. I'm left with dy dx is -6xy minus 4y squared over 3x squared plus 8xy. You'll have some complicated looking things that are your derivatives, but that's typical with implicit differentiation. All right, let's look at number 2. All right, and you have a multiple choice, but again, with those, I would say let's do our work and then try to match the answer. So we have x to the 4th plus y to the 4th equals 20xy. Remembering this is a product. So on the left side, we take the derivative of both of those pieces. So we have 4x cubed plus 4y cubed dy dx equals 20x, that's the first, times derivative of the second, plus second times derivative of the first. So let's do this. Got a derivative there and a derivative there. All right. Next line, we're going to take those derivatives. The derivative of y is 1 dy dx. Derivative of 20x is 20, and we've got that with that y there. All right, so we start cleaning up. 4y cubed dy dx minus 20x dy dx. What did I do? I moved this term to the left, and I moved the 4x cubed. I didn't move him at all. So I just moved this over here, and I've got 4y cubed dy dx minus 20x dy dx. And I did move that guy here. I did that all in one step. Probably shouldn't have done that for you. But so all the normal terms are over here. The dy dx terms are here. Then I factored out my dy dx and was left with 4y cubed minus 20x. I divided by that on both sides. And then I did do some cleaning up by factoring. Everything here would be divisible by 4. So that's 5 minus x cubed, 5y minus x cubed, and then y cubed minus 5x. And then we should be able to find our answer up there. Looks like that is B. All right, let's go to number 3. Same thing. We're going to do each term knowing that this is a product. So first times derivative of the second plus second times derivative of the first plus derivative of this is 2y dy dx. Derivative of x is 1 and derivative of y is 1 dy dx. So then you had 5x dy dx plus 5y plus 2y dy dx equals that. I need to get rid of this 5y. I need to move this to the other side. So when I've done all that, I have all my dy dx's here. I have a negative 5y and a plus 1 here. I factor out dy dx, left with that. And then I divide by that on both sides. And so I have dy dx is this term over this term. It really is the same process, just over and over. Just have to be careful keeping your terms straight. Let's look at number 4. 2y squared equals 5x minus 3 over 5x plus 3. Now we don't have any dy dx's over here, but we do have a quotient. So you have to follow that quotient rule. All right, so on this side, we've got 4y dy dx. Over here, we have that quotient. So bottom times derivative of the top minus the top times derivative of the bottom, all over the bottom squared. We took the derivative here and here, and then we can go ahead and distribute here. I wrote that this is 25x minus 15. And then I multiplied these two together and had 25x plus 15. I applied this minus to both of these terms, so you have this. The 25x's cancel each other out. I've got 30 over this. Now I can divide by 4y. So I have this business. And remember, when you have a double denominator, this part of the denominator can come right here because they're both being divided. So dy dx is 30 over 4y times this squared. And 4 and 30 both are divisible by 2, and that's what I did there. So that one is pretty straightforward. All right, number 5. X equals sine y. So the derivative of x is 1. The derivative of sine is cosine y dy dx. Go ahead and divide by cosine y, both sides. So now you have 1 over cosine y equals dy dx. If you can make it one simple trig function, 1 over cosine is equal to secant, so we don't have a fraction. I would say go ahead and do that, and that should be your answer. Number 6, x to the 5th plus sine y is equal to x cubed y to the 6th. Over here, pretty straightforward. We have 5x to the 4th plus cosine y dy dx. That took care of the left. Here we have a product. So first times derivative of the second plus second times derivative of the first. Derivative of this is 6y to the fifth dy dx. Derivative of this is 3x squared. So we just took the derivatives in that line. Now we combine these and we have 6x cubed y to the fifth dy dx plus 3x squared y to the sixth. So I subtracted this to the left, this subtracted this to the right. So now I've got all my terms on the right side that I want them on. I factor out dy dx, left with this, divide by this, and there's your answer. Right? Number 7, e to the 9x equals sine of x plus 2y. All right, so on the left, we've got e to the 9x times 9. On the right, we have a trig thing, so it's cosine, derivative of sine is cosine of x plus 2y times the derivative of x plus 2y. So next line, we're going to take the derivative of this. Derivative of x is 1, derivative of this is 2 dy dx. I need this to just be dy dx. So these are being multiplied. I'm going to go ahead and divide by cosine x plus 2y. So I did that there. So now I have this line. That's after dividing. I also want to get rid of this 1. So subtract 1 and divide by 2. So this is a double denominator. I can move the 2 up here. So I have 9e to the 9x over 2 cosine x plus 2y minus, now this 1 up here has also the denominator of 2, so minus 1/2. That is the way they'd like the answer. So that's split into 2 pieces. All right, number 8. Tan of r theta squared equals 1/6. Easy on the right, the derivative of a constant is 0. Derivative of tan is secant squared r theta squared times the derivative of r theta squared. Well, r theta squared is a product, so first times the derivative of the second plus second times derivative of the first. That should be a dr. I don't know what happened to that little letter there, but it's not a minus. Let's fix that real quick. I don't know why that keeps doing that. Let's see. Okay. That looks more like a dr now. That was bothering me. Okay. So then when we take the derivative of theta squared is 2 theta. The derivative of r is 1 dr d theta. All right, so combining we have 2r theta plus theta squared dr d theta times this. Now we can distribute if we, so this is multiplying here. We really only want to have this. So honestly, we don't have to do any of this multiplication. We can divide by this, and you should see if you divide, it's gone because it's dividing into 0. So now I have this line. Subtract the 2r theta to the other side, and then divide by theta squared. We're always trying to isolate this. So dr d theta equals negative 2r theta over theta squared. Those can simplify, and you would have just a theta on the bottom. So negative 2r over theta. Number 9, you are asked to find the first derivative and the second derivative. So this will be a little bit of work. All right, so let's do the first derivative first. And I've done that over here. So you have 6x, here's that, plus 8y dy dx, subtract the 6x, divide by the 8y, and simplify. So the first derivative is negative 3x over 4y. They did ask for that answer. Now you know that that's what dy dx. So we go ahead and use this to take the second derivative. And so here we go. That is a quotient. So denominator times derivative of the top minus the top times derivative of the bottom over the bottom squared. Those two derivatives are pretty simple. That's a negative 3. That's a 4 dy dx. So here we have negative 12y, and then minus, and inside here we've got negative 12x dy dx. And so that's what we have there. All right, so we did that, and we have this minus is going to distribute there. So we have negative 12y plus 12x dy dx. At this point, when we've only got this dy dx, we're going to substitute what we know dy dx is. It's negative 3x over 4y. So we're going to plug that in there. So we have negative 12y plus 12x times negative 3x over 4y over 16y squared. Multiply this on the top. We have minus 36x squared over 4y. All of that over 16y squared. We want to make this be one fraction. And before I did that, I did simplify 36 and 4. So I had 9 over 1. All right, now this is a 1, this is a y. So we're going to multiply y here, and we have negative 12y squared over y. That's the same as this. Minus 9x squared over y over 16y squared. That's a double denominator. This one's going to come up here and be 16y cubed. So that is, this minus, you could have left it like this, but since you're choosing a multiple choice, you can see that they pulled this negative out of these two, put it out front, and there's that answer. So if you are in that position where you're just having to pick, you may have to rearrange your signs to match, but we definitely had the right answer. All right, last question. That one is omitted, and then this is your last one. This is number 10. Find the lines that are tangent and normal to the curve at the given point. Remember, we said that at the beginning, the tangent line and the normal line. So you've got this equation at this point. So if we're taking the derivative of this, that's a product on the left. First times derivative of the second plus second times derivative of the first, derivative of 36 is 0. So I have x times 2y dy dx plus y squared times 2x. Clean that up a little bit, and I am left with this. And I'm going to I'm going to, I don't know why that happened. I was reading that wrong. So I subtract this 2xy squared over here and then divide by 2x squared y. So I'm left with dy dx equals negative 2xy squared over 2x squared y. Those twos cancel out. I'm left with a negative. The x is gone and you just have an x on the bottom. This y is gone and you just have a y on top. So my dy dx is negative y over x. And the point that they gave you was 2, negative 3. So at 2, negative 3, dy dx is negative of this, so that's a positive 3, over 2. That gives me my slope. This is going to be the slope of the tangent line. So using this point and this slope, we use our point slope form and we get the tangent line y equals 3/2 x minus 6. Now for the normal line, it is a negative of that slope. And in reversed. So this is negative 2/3 instead of a positive 3/2. It's the negative reciprocal. Use the same form, same point, but a different slope. And you get negative 2/3 x minus 5/3. That is the normal line. And the question asked for both equations. Your y equals is here already, so you're just putting in this part and this part. And that will get you going on implicit differentiation.